Hello class, this video will give you a review of implicit differentiation, also show you the explicit differentiation, and review why we like to do implicit. So first of all, we take a look at this equation, y squared minus 4y plus the x equals x squared plus 6x plus 2, and we want to take this derivative with respect to x. So implicitly, this will be 2y, but that was taking the derivative of the y variable with respect to x, so dy dx, minus the derivative of 4y is 4, and again, that was dy dx, and that will equal 2x. Now that's dx dx, the derivative of x with respect to x, so we don't need to write it, plus 6, again, don't need to write that because that was the derivative of x with respect to x, and 2 is a constant, so we have the plus 0. Now on this left side, I see that I have 2 of the dy dx's, so we take 2y minus 4 in parentheses, dy dx, and I just factored that dy dx out, and on the right side we have the 2x plus 6. Now, we want to get dy dx by itself, so we divide both sides by the 2y minus 4, and now you might notice that all of this is divisible by 2, so if we see that, we write this as dy dx equals 2 times the quantity of x plus 3 over 2 times the quantity of y minus 4, and the 2's will cancel, and we get a final answer here that dy dx will be equal to x plus 3 over y minus 4. Okay? So, excuse the handwriting, but there is the best we can do for implicit differentiation. X plus 3 over y minus 4. Now we'll show you what would happen if we tried to do this explicitly. Explicitly meaning if we tried to solve this, solving for y. So our first job will be to solve this for y, and so we will call this y squared minus 4y. And then we're going to set this equal to this, but now what we need to do is we need to get y by itself. So we need to complete the square. So we'll decide to add 4 to this side and add 4 to the other side. And this will leave me with, on the left hand side, from completing the square, y minus 2, the quantity squared, equals the x squared plus the 6x, but now it's plus 6. So now what I'll want to do is I'll want to solve for the y, so I'll take the square root of both sides. Remember, the square root of a square is an absolute value. So technically, this is what we have. But to solve that, what we say is that y minus 2 equals plus or minus that square root of the x squared plus the 6x plus the 6, and then y equals 2 plus or minus the root of x squared plus 6x plus 6. Okay, and so all of that is just to go ahead and get y by itself. Now you'll notice that this does not predict a function, it predicts two things. For this y value, when I put in this x value over here, when I put in an x value, each time I put in an x value, we're going to get two answers to it. We'll get 2 plus what that value is, that square root is, and we'll get 2 minus what that square root is. And so we'll end up getting 2 y's for every 1 x that we have as an input. So to take the derivative, which we'll do on the next slide, we have to consider both of these and do them separately. But for simplicity's sake, I'll just pick y equals to the plus, that square root on the next slide, and we'll take that derivative. And we won't do the negative one until we won't probably get it done, but we'll talk about when we get done. So, slide, in this case, we are going to start taking the derivative. Now y is by itself, so we'll call this, the derivative of y is 1, so it's 1 dy dx, equals the derivative of 2 is just 2. Like I said, we're going to use the positive, so this will be positive 1 over 2 times that square root of that stuff in front of there. Hopefully we've done enough derivatives of square roots so that we know it's 1/2 times the square root of that in the denominator. Now I need to take the chain rule and take the derivative of x squared plus 6x and multiply this. So that's times 2x plus 6. And there is my derivative doing that explicitly. However, we want to clean this up. We notice that the top has a 2 in common and the bottom has a 2 sitting out there. So dy dx equals 2 times that quantity of x plus 3 over 2 times that quantity of the x squared plus the 6x plus the 6. Okay, the 2's will cancel, and we notice that we have dy dx equaling the x plus 3 over the square root of x squared plus 6x plus 6. Alright, but as you might notice as I flip back to the other slides, that we do not have the same answer. What we notice is that we don't have the same answer as the first one. When I did this implicitly, it said, if you remember right, that dy dx equals x plus 3 over y minus 2. And that is not what we're seeing over here. However, I do remember some things that I can take from the previous slide, and that the fact that I should know that y minus 2, the quantity squared, y minus 2, that quantity squared, was equal to x squared plus 6x plus 6 after I completed the square. So, because I know that, I'm going to replace the denominator in here with that information, and we'll say that dy dx will be equal to the x plus 3 divided by the square root, and now we replace that x squared plus 6x plus 6 with y minus 2, the quantity squared. Once again, we have a square root of a square, so we're in a conundrum on the plus or minus here. We're going to ignore that just for a second and keep it as positive, and this becomes x plus 3 over the y minus 2, the quantity squared, which is, that square root is simply y minus 2. Now we did this because this was only the positive side of it. Now if we were to redo this with a negative, what would switch is, of course, we would have, if we're going to do this with the negative, then at this first section here we'd have a negative, and then of course we would have a negative on this, and so we'd have a negative outside of there, and then we'd have a negative outside of here, and then this is, when I would take the derivative of the denominator, that's where we can have the location there, the plus or minus and the denominator, and those can cancel and can get me right back to where I started. This is taking care of an implicit because x and y have to be an ordered pair that are on the curve, and that's the same thing up here. So we do actually get to the same answer, but one of the routes is a lot quicker than the other. I hope that helped show the difference between implicit and explicit, and hopefully you agree with me that it's much easier just to do the implicit differentiation from the beginning. Okay, the next video will be something about taking the second derivative with these, so stay tuned for the next one.